Algebra 1. Okay, our lesson today is another method for solving quadratics. Okay, so far, what we have done in solving quadratics, we have done solve by factoring. We've also done solve with square roots. So solve by factoring, basically it works when you can factor. So for example, if I had, x squared plus 6x plus 5 equals 0, then that's x plus 5, x plus 1. My solutions are -5 and -1. So it works when you can factor. Solve with square roots works when you're missing the x term. So when you have something like, 4x squared equals 36, then x squared equals 9, x equals plus or minus 3. You end up taking the square root of both sides. That only works when the x term is missing, when the only term is an x term. Now, let's talk about this. Let's talk about something called completing the square. It's a way of making a trinomial a perfect square. So let's look at this. X squared plus cx plus d, excuse me, x squared plus 6x plus c. What value of c will make this a perfect square? You can look at this geometrically. So this distance from here to here is x. This distance from here to here is x. That's why the area is x squared. This one is 1, this is 1, and this is 1. So those rectangles are 1 by x. Their area is x. This is 1, 1, and 1. So 1 by x. So the distance here is x. So in each of these little squares is going to be 1 by 1. So how many do I need in order to make it work? Well, you can count them up and see that I need 9 of these, okay? So in order to make this a perfect square, this number right here has to be 9, okay? So what would happen if I get x squared plus 6x plus 9? Now let's try to factor this. I need numbers that multiply to 9 and add to 6. So the only factors of 9 are 1 and 9, 3 and 3. The only way to get it to add to 6 is 3 and 3. So this is x plus 3, x plus 3, otherwise known as x plus 3 squared. And that's what I mean by completing the square. I make that trinomial a perfect square. So this trinomial right here can be written as x plus 3 squared. Let's look at the next one here. What can I do here to make this a perfect square? So in this particular case, you've got x squared so if I look at this particular case, you've got x squared minus 2x. In order to make this a square, I need to add a 1 right there. Okay, so this is going to be x squared minus 2x plus 1. Now, if this factors, I need numbers that multiply to 1 and add to -2, where those are just -1 and -1. So this is x minus 1, which is just x minus 1 squared. Okay. So what we need to look at is the relationship. What makes it a perfect square? What's the relationship between 6 and 9? In this particular case, what's the relationship between -2 and 1? It's the relationship between those numbers that makes me have a perfect square. So let's look at this one. Can I factor this? So I need numbers that multiply to b over 2 squared and add to b. Well, what numbers multiply to b over 2 squared? And since I want it to be a perfect square, really the question is what number multiplies by itself and gives me b over 2 squared? Well, that's just going to be b over 2, because b over 2 times b over 2 equals b over 2 squared, and b over 2 plus b over 2 equals b. So what it tells me is the relationship to make a perfect square, you take 1/2 of that number and then you square it. That's going to make your trinomial a perfect square trinomial. So just by taking half of the number that's in front of x and squaring it, if that's your constant term, then this is going to factor as x plus b over 2 times x plus b over 2. You shouldn't have to write that down too many times. Basically, it's x plus b over 2 squared. Okay. So basically, if I look at the middle term, if this number is half that number squared, then that makes it a perfect square. This is x plus b over 2, all of that squared. So let's put this to work. Let's use completing the square to solve this particular trinomial. Okay, so x squared plus 8x, and I'm going to write a space here, equals 0. Now, in order to make this a perfect square, I need to take 1/2 of 8 and square it. So what's 1/2 of 8? That's 4, so this is 4 squared. So I'm going to add 4 squared here, okay? If I add 4 squared on this side of the equation, I also need to add it on this side of the equation. Now, if you look at this, the reason we did this is now this will factor. So this number is 16. What numbers multiply to 16 and add to 8? That's 4 and 4. So I should be able to just go and say this is going to be x plus 4. So x plus 4 squared minus 10 equals 16. So this is, if I continue on, x plus 4 squared equals 26. Now, what method can I use to solve? I can solve this using square roots. So if I take the square root of both sides, x plus 4 equals plus or minus the square root of 26. So x is negative 4 plus or minus the square root of 26. Those are my two solutions. Now this one could not have factored. Like the numbers that multiply to negative 10, what 1 and 10, 2 and 5, there's no way to add those numbers and get an 8, okay? So this one would not factor. And I can't solve it originally with square roots because there's that x term, but I can do what's called completing the square. So again, what you do is you take half of that number and square it, add it to both sides. So what that does is it creates a perfect square, x plus 4, all of that squared, minus 10 equals 16. That allows me then to write this as a perfect square. Let's convert this polynomial from standard form to vertex form. So in order to do that, so I've got f of x equal x squared plus 8x, and I'm going to write minus 10. I'm going to leave some space here. So in order to make this a perfect square, I have to add half of that number squared. Well, if I add it, I'm also going to have to subtract it in order to keep that function the same. So this is x plus 4 squared, and then minus 26. So this is, that polynomial has been moved from standard form to vertex form. What is the vertex of this polynomial? So the vertex is what? Negative 4, negative 26. So again, all I'm doing is what's called completing the square. The key is you take half of the linear coefficient and square it, and then that creates your perfect square. Because think about this, what numbers multiply to 16 and add to 8? Well, that's a 4 and a 4. That's why I like to write this guy as 4 squared. That way, when I go to this answer, I basically just copy x plus 4, and then all of that squared is the perfect square. Use completing the square to solve this guy. So x squared minus 8x, and I'm going to write this one, equals 4. I'm going to move that constant to the other side. So now what needs to happen to complete the square, what's half of 8? That's negative 4. You square it is going to be 16. So I basically I don't need to be concerned with that negative. It's going to be a positive. So if I add a 4 squared to that side, I have to add a 4 squared to this side. So again, numbers that multiply to 16 add to negative 8. That's negative 4 and negative 4. The way I just typically do it is x, copy this sign, minus, copy that 4. This is x minus 4 squared equal, what is this, 20? Now to solve it, you take the square root of both sides. X minus 4 equals plus or minus the square root of 20. So x equals 4 plus or minus the square root of 20. I'm probably not going to be too picky about it, but your Algebra 2 teacher and your Geometry 2 teacher will. But the square root of 20 is not in simplest radical form. So that's the square root of 4 times 5. So that's 2 root 5. So I know your next honors teacher will probably want to see 4 plus or minus 2 root 5. Convert this from standard form to vertex form. So f of x equals x squared minus 8x, and I'm going to write minus 4 over here. So half of negative 8 is just going to be 4, so I'm going to add 4 squared. If you add 4 squared, you also have to subtract it to keep that equation correct. Then this becomes x minus 4. Okay, so x minus 4 squared, and then that's minus 20. So this is in vertex form. The vertex of that parabola is at 4, negative 20. Now, it gets a little bit complicated when the number in front of the x squared is not a 1. So let's rewrite this. This is what, 2x squared plus 4x equals 5. If I subtract that 5 from the other side. Now let's factor out the 2. 2x squared plus 4x, and now I'm going to leave some space here to complete the square. So you add half of this number, half of that number squared. So that's going to be plus 2 squared. Okay, so that's adding 4, right? But you have to keep in mind, how did the left side of the equation change? Did I add 4? Well, no, you have to keep in mind that what you really did was you added 2 times 4. So you have added 8 on the left side of the equation. So what must you do on the right side of the equation? You must also add 8. So this gives me 2x plus 2 squared equals 13. Now I can divide by 2. X plus 2 squared equals 13 over 2. Square root of both sides. X plus 2 equals plus or minus the square root of 13 over 2. Final answer, x is negative 2 plus or minus the square root of 13 over 2. So again, a little bit more involved when the number in front of the x is not a 1. that you have to always factor that number out. Let's convert this to vertex form and solve when f of x is equal to 10. So f of x equals 2x squared plus 4x plus 5. I have to factor out that 2. So 2x squared plus 2x. Now to complete the square, half of that number, right? Wait, did I do that wrong in the previous one? Oh, I did make a mistake. I got to go back. So this is, go back to here. I made a mistake in the factoring. So let me back up. When I factored out that 2, this is going to be x squared plus 2x equals 5. Half of that number, this is just going to be a 1. Half of that 2, so this is what I have done effectively. I have added 2 to the left side of the equation, so I have to add 2 to the right. So this is 2x plus 1 squared equals 7. X plus 1 squared equals 7 halves. X plus 1 equals plus or minus the square root of 7 halves. Final answer, x is negative 1 plus or minus the square root of 7 halves. Okay, made a mistake there algebraically. So here, when I see this, now to complete the square, half of that is 1, so you add 1 squared, but technically I have added the value of 2. So I'm on the same side of the equation, I have to subtract 2. So this becomes f of x equals 2 x plus 1 squared plus 3. So that is this equation. There's a parabola with a center at what, negative 1 and 3. Now solve f of x equal 10. F of x equals 10. Set that equal to 10. So 2 x plus 1 squared plus 3 equals 10. 2 x plus 1 squared equals 7. X plus 1 squared equals 7 halves. I'm getting the same answer that I got up here. So x plus 1 equals plus or minus the square root of 7 halves. X is negative 1 plus or minus the square root of 7 halves. So it's a little bit more of the algebraic work involved. I expect to get the same answer because this is saying f of x equal 10. This is saying f of x equal 10. So I should have gotten the same answer on both of those. So anytime you're completing the square with an ax squared where a is not 1, you have to factor a from the first 2 terms. Now, if there is a reason why I would say students don't like this method is what happens in this next problem. So you're going to have 2x squared plus 3x equals 10. Now I have to factor a 2 out. So this is 2x squared plus, when you factor a 2 out of the 3, you're going to have 3 halves x. Because when you multiply 2 times 3 halves, you get the 3x. So now I've got a fraction. So I need to figure out what is 1 half of 3 halves, and then I need to square that. So half of 3 halves is what? 3/4. So this is 3/4 squared. So I've got 2x squared plus 3 halves x plus 3/4 squared. I always leave it 3/4 squared because that's the way I'm going to factor it. So what have I added to the left side? I have added 2 times 3/4 squared. That's 2 times 9/16, which is what, 9/8. So if I add 9/8 to the left, I must add 9/8 to the right. So this is 2 x plus 3/4 squared equals, so what is 10 plus 9/8? I think that is 89/8. So 89/8. I'm going to divide by 2, right? So x plus 3/4 squared equals 89/16. I'm going to take the square root of both sides. X plus 3/4 equals plus or minus the square root of 89/16. So x is negative 3/4 plus or minus the square root of 89/4. Those are my answers. So again, it's a little bit algebraic when it comes to solving this, but we're doing the same process over and over. Sometimes the numbers are not fun to work with. If I convert this guy to vertex form, so f of x equals 2x squared plus 3x minus 10. So f of x equals 2 x squared plus 3/2 x. In order to do that, it's 3/4. So I need to add 3/4 squared. And remember we said that that was 2 times 3/4 squared. That is 9/8. So if I'm adding 9/8, I must also subtract 9/8. I'm on the same side of the equation here. So this gives me 2 x plus 3/4 squared minus 10 minus 9/8. So f of x equals 2 x plus 3/4 squared minus 89/8. And that's in vertex form. That leads us up into the homework for this section. So again, guys, you're going to need to practice this. This is a new skill. It is sometimes algebra students' least favorite thing to do with quadratics. But there's a method to this of working these. So all of these are going to have the same method. You're going to love it when there's an x squared here because all you have to do is take half of that number squared and add to both sides, okay? So when there's an equation, you're basically adding this to both sides. And easiest thing to do would be go ahead and get this guy like this, and then you're going to add 2 squared over here, add 2 squared over here. This is just x plus 2 squared equals 14, and you go from there, okay? Where they get more involved, like I said, is when the number in front is not a 1. Now you always want to try, if there's a greatest common factor, do that, okay, from all of these, because it could reduce it down to one that just has an x squared, okay?